being here. I hope the conference has been going well for you so far today. I feel like this talk will be interesting if you were just in Matt's talk about cloud security. It gets a little in the weeds about a specific application vulnerability relative to Entra ID, and right, and so this is defenders hate it, compromise vulnerable SaaS applications with this one weird trick. I've also given this talk with getting developers to follow standards is easy, and other lies we tell ourselves as the title. Even though it relates to Entra, a lot of this is rooted in developers doing their own thing here. So, and there's a good amount of stuff to cover just before we get into things though. So I'm Woodruff, currently Chief Identity Architect at Semperis. We do a lot of Active Directory and Entra ID, which was Azure AD security stuff. Before this role, I was on our security research team, researching various things with Entra and Azure and all that stuff for about a year. Social media handles, I don't have any sort of cool hackery handles here, but hopefully, Eric on identity is easy to remember enough, and you can find me pretty much on most of these things, mostly active on LinkedIn though these days. So, just going to have a bit of a backstory here, right, on the research that we did and what this was rooted in. And in particular, right, this is around this no-auth vulnerability, right? And so this was disclosed by Omer Cohen of Dscope on June 20th of 2023. And right, you might get into it and say, well, why are we here 2.5 years later talking about something like this, right? But we'll hit on that. Right, and this is a vulnerability in applications using OpenID Connect, right, which is sort of the modern way of authenticating to SaaS applications out there, specific to Entra ID. And the vulnerability was essentially rooted in anti-patterns with OpenID Connect, right? So an anti-pattern is, again, developers going to develop, they're doing their own thing, or not implementing, spec or standard as they should. So when essentially, right, with this allowed a vulnerable application for takeover, right, a user impersonation of any user in a target app, right, that was vulnerable if you knew the person's email address, right? So if the app was vulnerable and I knew your email address and you used that application, right, I could essentially get into it as you and do whatever I wanted as you and whatever that application is, right? And so, but in their research, this is essentially what, we'd say is a cross-identity provider, cross-IDP type attack. So right in their research here, we'll sort of walk through, right, that essentially a legitimate user in this example authenticates with Google. Now we're using Adobe here, Creative Cloud as an example. I don't believe this was ever vulnerable to this. Right, but so they authenticate with Google, say it's a shop that's using Google Workspace, primarily, right, for user accounts in this system, right? We're an enterprise, university, something like that. An attacker goes and configures an Entra attack tenant, right? So it's easy to get your own Entra tenant, a million different ways that an attacker can sort of go acquire one. They basically set a user account with an unverified email address with an Entra. They then authenticate, with Entra to this vulnerable application, and the application has flawed account merge logic in here. And essentially, right, the user is able to get in as you, or as whoever they're targeting here in this cross-IDP type attack. So when we talk about the account merge logic, all right, so here I am in that vulnerable SaaS application that we're looking at, right? And my email address, eric@fabricam.com here. Right, and again, I'm using that Google account where I'm eric@fabricam.com because we're a Google Workspace, shop here, right? So when I authenticate sort of high level, right, this is what's letting me in. The attacker shows up with this Entra account, right? And they, again, can go say, I'm also eric@fabricam.com. Right, and so generally what happens here in SaaS applications that support, lots of different IDPs, there's this, account merge logic, and what this looks like is, right, you'll get some sort of email where there'll be basically like an MFA type thing, right? It's you get an OTP code, a magic link, something where you basically have to prove like, hey, right, this is in fact you. You get an email, right, you have to sort of say, yep, it's me, because it's going to your inbox here, right? And then you get, once you verified it, you'll get another email saying, hey, we see you signed in with a Microsoft account, right? You usually use Google, so on. But right now, if the logic is either flawed or missing here, essentially what would happen is an attacker could then authenticate, right? So in these instances from Dscope's research, that piece didn't happen or there was something broken with that, right? So essentially because we're not verifying that you in fact own that email address, right, then an attacker who's basically saying they are you, we're able to get in. And we'll get into like how the attacker is able to do that from an Entra perspective. But right, if we look at a timeline again, right, here we have, June 20th, 2023, when Dscope, released this research, and today, and again, right, you may say like, well, who cares? Now, interestingly, right back when this came out, when Dscope released it, they had coordinated with MSRC, right, Microsoft Security Response Center, to discuss this, right? And basically, at the time, Microsoft came out with this customer impact statement. Man, I don't have my my glasses with me, so it's hard for me to usually read this piece. But basically, what MSRC is saying here, right, is that they are able to catalog all the vulnerable applications. They contacted the application owners of all the vulnerable applications, and the TLDR on it is sort of Microsoft saying, like, anyone that was vulnerable, we contacted the app owners, and like, hurrah, everything's resolved here. And along with this, right, a lot of reporting on this, basically said that this is something that was fixed, right? So, Hacker News, Bleeping Computer, right, they came out saying that, it enabled, right, sort of past tense, and then, Microsoft fixes, right, this problem with this no-auth flaw. Again, Petri, another, popular site here, right, saying that Microsoft patches, this critical no-auth flaw, right? And this is very critical, again, going to the point that if you know someone's email address, right, you can effectively get into that SaaS application as them. And actually at the time I kind of, complained about how this was being reported on, but that's neither here nor there. Right, so, we have our timeline again, and basically right when it's released, right, basically we're claiming no auth was fixed here. And interestingly, a few weeks later, the Storm 0558 incident happened at Microsoft, which was the big signing key theft thing that consumed a lot of, news cycles around Microsoft. I think, I bring it up here because it overshadowed, the no-auth flaw, and I think some of the attention that it should have gotten back then. And, again, you could still say, well, right, who cares? So last fall, we basically were researching no-auth and trying to build off the work that Dscope had done, right? And, unfortunately or fortunately for us to have something interesting to talk about, right, finding out that no-auth is actually still alive and well out there. So, Dscope's research, again, was a bit of a cross-IDP type attack, and we were really focused on just Entra cross-tenant attacks. So, right, in these scenarios, you again have a legitimate user, right, authenticates to Entra. Again, that attacker is going to go configure their own attacker Entra tenant that they can easily acquire. With that user's, right, the target user's email address as an unverified email attribute. The application is not following OpenID Connect standards here for how authentication should take place. So essentially, this is a cross-tenant type attack, right? So in this scenario, the IDP or the application only needs to have support for Entra here, right? And I want to highlight this because in that initial sort of news cycle around this, I think a lot of developers were like, well, we don't do Google, or we only use Entra or Azure or Microsoft 365, whatever you want to call it, right? So we can't be vulnerable to this sort of attack. And that's what we're going to get into, in that applications, as we've found here, can be vulnerable to this if they only support this Microsoft sign-in. So digging into things a bit here, and now I'm an identity nerd, so I'm going to try to lay some groundwork here, because everyone probably isn't as nerdy as me, which is probably a good thing about identity here. And I just want to talk about OAuth and OpenID Connect, right, and sort of high level what these things are, just so we kind of have a baseline of understanding here, right? And so OAuth is used for authorization, right? So this is, I've already authenticated, and I want to have access to something, right? You're being authorized to have that access. OpenID Connect is actually used for authentication. It's built on top of OAuth, OAuth 2 specifically. But OpenID Connect is basically a thing that says, like, you can go to a SaaS app and say, yes, this is Eric, I know he authenticated here. Both of these use JSON web tokens, which are usually shorthanded to just a JOT or JWT. Right, and OAuth JOTs are access tokens, and OpenID Connect JOTs are ID tokens. Now, also I kind of highlight this for, the focus here is really around OpenID Connect, but Dscope named this NoAuth, so people sort of get confused in their head thinking it's a OAuth problem, but it's really a flaw within OpenID Connect, which is why the name doesn't necessarily align to sort of what we're digging into here. And also just want to talk about claims, right? Again, identity people like to come up with all sorts of weird, names for things, right? Claims really is just data an application wants about a user, right? So in these ID tokens, there's going to be, claim information, and this is stored as attributes in Entra ID, right? So, my first name, last name, my email address, right? Basically things an application might want to know about me for whatever that application is doing. It can ask the identity provider, Entra ID, for claims about me, right? Essentially information. And how this works sort of within the Microsoft world of things within Entra ID, again, formerly Azure AD, is so if we look at a SaaS application here, right, and the SaaS application has this, sign in with Microsoft. It could be sign in with Office 365, right, sign in with Azure, whatever it is, it's all the same. It's Entra ID really under the covers here, right? There's this sign in button here. And so the application developer in their, their ISV, right, they're the software vendor tenant, they create this thing that is an app registration, right? And so in this example, it's this Contoso.com SaaS app. And then on the consuming side, right, so I'm a customer that wants to log into the application, I'm going to have this thing that's called a service principal, and this is basically the thing that allows authentication to happen from my tenant here. So there's a bit of a relationship between these two objects here. So, but essentially, like, the app registration is the developer's dream, right? This is like the developer defining like whatever it is that they want, this application to need, right? They sort of put that in the app registration. Again, it can be a public or confidential client, and this really means, right, is it like a thick client application? Is it a web application, stuff like that? And they can define other things about their application that we're not going to get into, but like basically URLs that the application uses. And again, they define claims, right? So here the developer is saying, right, this is like the information we want to know about, this user that's authenticating to our application. On the service principal side, right, again, this is the organization consuming the SaaS application. This is that security principle that allows authentication to happen from this tenant. So customers, they have to go through this app consent process when they first onboard an app, where they basically are like, yep, in the example of Adobe's Creative Cloud, right, yes, we want to allow, people in our organization to use Adobe Creative Cloud with our, Entra ID. And as I mentioned, right, this is what enables authentication or authorization. This is essentially the thing that says, hey, like, I'm going to give out ID tokens, access tokens, right, to Adobe Creative Cloud. So, right, again, we have this relationship between these things, and again, this is what facilitates this, sign in with Microsoft button. It's, it's similar when you might see a sign in with Google button, a sign in with Facebook, sign in with Apple. With Microsoft, how this is facilitated is they actually have these, common endpoints out here, and this is maybe a bit in the weeds, but essentially there's these URLs, right, that allow anyone from any Microsoft tenant to authenticate to the same endpoint. And this kind of facilitates this multi-tenancy thing that is, unique to Microsoft's implementation of OpenID Connect, right? And so high level, right, you think of any of those sites that have that sign in with Microsoft button, this is kind of all the guts underneath that is facilitating that button to sort of, magically work for enterprises and to know, where you exist within, all the different Microsoft tenants that would exist for, corporate Microsoft 365, corporate Azure, all that sort of stuff. So if we're following the OpenID Connect standard here, right, for how this button should work, so again, now we see on our left here as a consuming tenant, right, we have Eric at fabricam.com, and right, I basically want to go sign into this app, so I hit, sign in with Microsoft, and, once I authenticate and say I do my MFA and all that sort of stuff and it's good, basically an ID token, again, is generated. And it's probably very hard to read. Your eyes might start watering if you try to see all this stuff on here. But there's a lot of data in that ID token, right? And that is given to that SaaS application. And right, SaaS applications on the back end, they're going to have some sort of user table, user database. So essentially, right in that table, a lot of this stuff gets populated. And in particular, in that ID token, there's the issuer and subject claims, right? So this is attribute data about this user. And so specifically here, if we're following how OpenID Connect is supposed to work, the subject is actually, it's a pairwise identifier. It's essentially a hash of a unique application ID, of the user's object ID, and the user's entry tenant that they're coming from. And because it's a hash, right, it's a one-way function. So essentially this subject will guarantee to that application that if you get this subject in, because it's immutable, that you can absolutely know that every time you get an ID token with the subject that it's always Eric. It can't be anyone other than Eric. Like this guarantees that it's always Eric, right? And so hopefully the developer is following spec and standards, right? And they're storing that sort of thing in their user database on the back end. So for a vulnerable application, right, essentially here the flow looks similar to me as a consumer. I go to sign in with Microsoft, right? They get that ID token. But the problem is in their database here of user attributes, basically most of the time what they're doing is they're looking at the email address, right, the mail claim that's coming in, right? And again, as we're going to find out, this is something that is not immutable. It's a mutable attribute. Anyone can send this from any sort of entry tenant, right? So now we have in this scenario where a attacker comes along, right, and they set up their evil entry tenant, right, and they go to onboard that application, and now they have evil Eric here, who has a UPN of Eric at evil.cloud, but I'm going to go on this user account and also say I'm Eric at fabricam.com, right? I go hit the sign in with Microsoft button, right? The application gets that ID token, but it's like, hey, the email address matches, right? So this has to be the same Eric that's coming in, right? They're not checking that subject or the issuer to really see where this is coming from. So right, when we talk about this setting an unverified email address, then you might say, well, this is sort of stupid. Like, why does Microsoft allow this? Right, so for that unverified email address, unfortunately, it's required for how their guest user thing functions, right? So if anyone's ever received something in someone else's OneDrive or SharePoint, or you've done some sort of business collaboration stuff, right, where you're invited as a guest into someone else's entry tenant, that all sort of works off of these email addresses within here. And so unfortunately, right, Microsoft sort of architected themselves into this corner where they have a need to have email addresses that are not necessarily, right, tied or verified to that tenant. Right, and so here we're basically going to look at Graph Explorer, which is just a sort of easy way to work with Microsoft's Graph API, which is what is used sort of on the back end behind like the entry portal and stuff like this. Right, so here we basically are getting a user account here. Right, and so we're just running a get, and we're going to sort of scroll down here. And we're going to see that we have an email address here for Kenny Rogers, right, at something.onmicrosoft.com. Right now we're going to go run a patch operation. So a patch is just basically going to update this user's attribute data. Now we're putting in, right, Alex Wilbur here as an email address on this user. So we patched it, and then we're doing another get, right? And now we're going to scroll down and basically see that right now we have Alex's email address set on this account, right? Because we're in our own tenant, like we can do whatever we want with these user objects, right? So this is in the attacker tenant. I can do whatever I please with my user accounts in this tenant. Right, and so also we can sort of examine these claims with jot.ms, right? And so jot.ms is essentially, it's primarily a developer tool for examining jot tokens. So as you're building an application, a developer can basically send ID tokens or access tokens to jot.ms in various ways and basically have it decode these tokens, right? And so at the same time, we can sort of use jot.ms conceptually to sort of see how this abuse works, right? So if we go back to this diagram here, we can use jot.ms to basically retrieve this, ID token data, right, and see how this works. So this is probably a little eye-watering again, apologies here, but basically what we're going to see right now is we're signing in as a legitimate user, so Alex Wilbur at fabriccam.com, and this application is essentially configured, right, to be vulnerable on purpose here. So we do our MFA and all that sort of stuff. Right, and so we get this ID token here. And so the ID token and the underline, so I'll pause it here real quick. The part that's underlined there, right, is that mail claim for Alex Wilbur, right? So again, this is the ID token that the application would receive. It's basically base 64 encoded, and we just decode it, and we can see all these claims. And it's signed, right, so it's not encrypted. So it has a signature, but the data itself is, sort of readable once we decode it. Right, so now, essentially, as the attacker here, right, we'll see here in this example of, sort of replicating a vulnerable application, we're signing in as a different user account here, right? So this isn't Alex Wilbur. Once we do our MFA and all that sort of stuff, right, we'll actually see here again, though, that we have that mail claim here saying Alex Wilbur here, right, even though we're not Alex himself, right? So again, just sort of showing, right, this is the same ID token that the application would receive, right, which would then say, hey, this is essentially that same user. Right, so Microsoft has some mitigations out there, but unfortunately it's relatively easy to bypass. And so, this goes back to when they made the announcement, like, hey, we've fixed it all, like, don't worry, folks. Right, so if we go back to this diagram that we'll sort of keep looking at here and there, right, Microsoft does have this concept of verified and unverified email domains, right? So if you consume Microsoft services, Azure, Microsoft 365, right, and you're going to have Entra, they all have Entra under the hood, right? There's the ability to say, like, we own this email domain, right? And you go through where you usually set like an MX or text record or something, right, proving your ownership. Right, and so obviously the evil tenant here can't verify that they own, right, fabriccam.com, right, because they don't. But unfortunately, so a mitigation here is that app registrations created after June 2023, by default, have this remove unverified email claim set to true, right? So it's a setting on it where basically we'd say don't send that mail claim. So if we went and looked at that previous example, and it wasn't configured to be vulnerable, the attacker, when they sent that ID token along, there'd just be nothing there for the mail claim. It would be absent. But unfortunately, there's different ways to bypass this. So either the developer can go set this to false, right? So the developer has control to do essentially whatever they want on their app registration. So then go say it's false, right? But also any app registration created before June 2023 and was using the email claim, right, also is going to still allow that to happen. Now, right, Entra Azure AD has been around for over a decade. I mean, there's hundreds of thousands of SaaS applications out there already retrieving this claim, right? And this is the part where Microsoft's like, don't worry, folks, we went and contacted all the people that were using it. From talking with people, I don't know how accurate that is. Right, so in our research here, basically when we were trying to figure out, like, hey, we're digging into this vulnerability and seeing, like, are there applications still vulnerable? And to us, the thing is, like, well, how do we find applications, right, to sort of test for this thing? I mean, again, there's literally hundreds of thousands of SaaS applications out there, right? Some are very small, some are niche, but, right, think of all the apps out there and the SaaSification of stuff, right? So we decided we're going to look at the Entra Gallery. And so the Entra Gallery is essentially this catalog that Microsoft has with a few thousand integrations that basically a vendor can go say, hey, put my software, in this catalog. And it's supposed to just allow for slightly easier onboarding and discovery. It's mostly a dumpster fire, in my opinion, not my employer's opinion, but yeah, with the Entra catalog, you can go out here and you can basically filter by applications that use OpenID Connect, right? So we basically went out to the catalog and we found, all the OpenID Connect applications, and we're like, we're literally going to test all of these, well, almost all of them. So, at the time we were doing research, so last fall, we found that there's, 1,017 OpenID Connect applications listed out here. And of these, we had 104 that we were actually able to test. Now, we didn't want to sign up for trials or have to talk to salespeople or anything like that, right? So we were basically looking for applications that allowed some sort of, self-sign-up, self-service, whether it's a trial or just getting into the application, right? I mean, it's a smattering of how app developers essentially implement, right, sort of, right, access into their apps here. So we have 104 that we were able to test. Right, and we found 9 of these were vulnerable, and you might look at this diagram and say, well, that seems like a teeny tiny number, right? But again, if we're looking at out of the 104 we could test, right? If we're being sort of nice here, we could round this up and say 9% of applications we tested, right, were actually vulnerable to this. Now, when we first published this research, we had a lot of people asking, like, well, how many applications out there are actually vulnerable to this? Right, and I'm being cheeky here, right? We don't really know how many applications would be vulnerable to this. Nobody can really know. And now, I'd probably bet money to anyone in the room here that it's probably more than 10, right? I don't think that we found 90% of the vulnerable applications here and that there's just, 1 or 2 more lingering. Again, Microsoft should know how many apps are consuming this unverified email claim. But right, the problem is, and why they just don't go get rid of it across the board, is just because you're using that claim doesn't mean your application's vulnerable, right? So if we went and looked at the well-behaving OpenID Connect application at the beginning that was using the subject, right, claim, they may also still want to know my email address. Maybe they want to email me, right? And they don't feel like asking for email. And the developer's like, well, we can just get that as a claim, right? So just because they're consuming the claim, right, they're using that attribute, doesn't mean that they're actually hinging off it. But unfortunately, the only way to really know this is to actually ask the developer or, test the application and then tell the developer that they're, doing things wrong here, right? So not even Microsoft really has any way to tell if, like, that application itself that's consuming it is vulnerable. And that's really a crux, again, of them sort of engineering, architecting, customers there's into this hole. But so we go back to our timeline, and on December 3rd, we opened a case with MSRC, basically talking about our findings here, right? And this is where it gets concerning, because you could still say, well, so far we don't really know the scope of things, right, or what are these applications. So, in the testing of what we found here of these 9 applications, right, so one of them was a human resources platform, right? So it's not a big one like Workday, but again, it's a system that's just going to be filled with PII out there. There's another one that, now we're getting on close to a year, right, since we started researching this stuff, that is actually still vulnerable. We've contacted the app developer. We're still being nice because they haven't done anything about it. But it's a time management system for healthcare, again, that when we were poking at it has a lot of PII about essentially workers within this platform. A little less concerning, but this could still have some interesting data if organizations were using these knowledge sharing collaboration platforms, right? So like there's all these things that are like Visio diagram and architectural things and building corporate knowledge platforms that are SaaS applications, right? So we found 3 of these that were vulnerable. There's also a sort of video clip sharing platform for internal knowledge sort of things that it seems like if, as say a vendor, you want to have little knowledge bites that you share with customers. So this platform claims to have 45,000 different organizations using it. And they also, when we last checked, were also still vulnerable. It took them about 9 months of us nagging them constantly to even get a response from them. A business coaching platform with Office 365 integrations. And so this also gets a bit interesting because in this sort of example, for these applications that then integrate essentially back with 365 for email and OneDrive and all that sort of stuff, this would let the attacker right then get into whoever they're attacking's email account. So in our testing here again, right now, in our testing, we basically, as we were looking at, as mentioned, we're setting up an account in that system that was us, so that way we're only sort of playing with our own data, right? Because we're not looking to go actually like muck around and get into some sort of gray area with just going after arbitrary people, right? But in this example, we're then able to basically get into the calendar and mailbox from this platform of our, our user that was our own victim here. A construction site management platform, and again, another meeting scheduling platform that had Office 365 integrations in it. Right, and so this is where, as a security person, it becomes very concerning. So we're actually going to walk through. Now, I wish I had recorded this, but they fixed it before I was able to record it at a lower resolution. Basically, going after this HR system, and again, I've redacted out most of the identifying information from it. Right, so on our left we have our legitimate user. Right, so they're going to sign into this HR platform. Right, and so we authenticate. I could work on my video editing skills to cut out some dead time in there. So once we authenticate here, and we're going to sign in, and again, removing a lot of information that would easily identify this platform. But we go in here and we can see our users here, right? And so we could say I'm an HR admin, so I have access to like every user, everyone's PII, right? Guaranteed there's going to be social security numbers, addresses, all that good stuff, right, in there. And now on the right, I'm that attacker, right? So I'm using my attack entry tenant, right? And basically I'm signing in here as the attacker, but I've set my email address, right? I've gone on LinkedIn. I've easily figured out, hey, this company uses this vulnerable platform. It's going to take me like less than 5 minutes to probably figure out who their HR admins are. And these days, it also is relatively easy to deduce people's email addresses, right? It's first name, last name, first letter, various things like that. Right, and essentially now I am in here, right, as that user, and just sort of showing, right, that we're able to manipulate data as the attacker, right, and that it would actually be reflected, right, within the system as the legitimate user editing this stuff. So, it was a very concerning find here, right, because again, there's all these other SaaS applications that we have not tested here. Right, so and this is a bit of commentary, unfortunately, on the industry, which again I feel like sort of dovetails into some of what Matt was talking about before, right? So the day before we actually opened the case with MSRC, we started to contact the application developers about this, right? And essentially this is like what their response mostly felt like. So we did have one vendor who was great to work with, and they resolved this problem within a week. We had some back and forth emails with them, maybe slightly over a week, but yeah, we contacted them, super responsive, and it was a great experience in helping them fix that, and that was the calendar sort of platform. But unfortunately, right, again, the longest resolution is still ongoing. So right here, we're like a cybersecurity company trying to contact app developers to say, hey, like, we can get into your app as your, customers essentially, right? And there's no response from a few of these vendors. And this gets into, right, it varied in how easy it was to report the problem. Some vendors had like vulnerability reporting database systems that didn't seem to matter, because one of them that still actually took about, I'd say, 5-6 months to get fixed, we actually reported it in that. We didn't hear anything for a couple months. We reached back out to them. We opened a support case with them, right, trying to get like a hold of people in various ways. And they actually would say, oh, well, we had this vulnerability, reporting database. And we're like, that's cool. Like, we filed this thing back in December, and, like, we're not looking for props here, but we're hoping that you're actually going to do something with this data we reported. And that again gets into, like, if vendors responded, if at all, right? Like, and I get that some vendors probably get hit with a lot of people who want, money and things like that. But we're just like looking to like make their authentication not suck, right? So that their customers are actually safe. We're not asking for anything in return here. And also, interestingly, some of these vendors, a few of these applications actually removed their Entra integration. And so when I was talking with MSRC, it actually seemed like they couldn't figure out how to fix it. So they just said, well, we're just not going to support Entra ID anymore. And one of them that actually is still vulnerable, we paid for a demo. It was very cheap. But it seemed like actually that they just put up a paywall, right, to prevent people from actually testing this. So, I mean, I don't absolutely know if that's correct, but it seemed interesting, right? We report a vulnerability. Every few months or so, we'd go to sort of retest these applications. Then we find out that they've changed, their flow because the demo was only like a month long or something, right? Where now we have to basically give them a credit card and sign up for a trial here, and then we do it and find the app is still vulnerable to this, right? Probably not a good look on their part. So from a MSRC case perspective, also, I've had some cases with MSRC, and it can vary greatly. And unfortunately, this case is also a bit, I guess I'd say, I didn't have a great time with MSRC. So again, we opened that case on December 3rd. December 4th, right, we get a response back from MSRC the day later. Again, we had that one application on December 17th. That was very responsive, and we went and resolved this with them. And then sometime in December, we were awarded 60 points. And so if you're familiar at all with bug bounty systems, usually if you get points, or at least in the Microsoft world, it means that they're taking your case serious because points equate usually to money and also like, other, thanks from Microsoft or whatnot. So we're like, okay, like they must be taking it serious. But we wait a couple months, right? They're busy doing their MSRC stuff. And, we haven't heard anything. So we reach out to MSRC asking about the case. And we also notified them that we're going to start talking about this, right? So we feel like we've waited long enough. It's already a disclosed vulnerability, right? Essentially from Dscope. And we're basically trying to ask them like, hey, like, it feels like a bit of a gray area, right? We think that customers, organizations should know. It's already been previously disclosed, right? We feel like we found a quote variant of it. Like, what do you want us to do about this thing? Right, and basically a day later, the 60 points were gone. So we're like, well, obviously someone at MSRC is listening, but it seems like we've just upset them by asking about it, right? Because we go in the portal and the points are missing, nothing's changed on the case. So now we're like, hey, like, obviously you guys are reading our email here, right? Because where'd the points go? And then a month later, they close the case basically with no response at all to us. So a few weeks later, after, the initial wave of anger at them sort of rolled off, reached out to their MSRC listens email address, which is like right where you go when you feel like they're not listening to you. And we got some initial response there, but even there, right, we've still never really had like a good sort of follow-up, right, because we just want to know why the process broke down. Again, right, we're just asking what we felt like were legitimate questions about the case, and wanting to be able to disclose it properly. But then interestingly, when we initially were going to talk about this at Troopers, which is a very big Microsoft-focused security conference in Germany, about a week and a half before that, all of a sudden MSRC starts reaching out to us asking if we want to talk to them, right? So again, funny that now that we're like, well, you guys obviously don't care, right? It's more than 3 months after the case was closed, which they basically say that once the case is closed, 30 days after you can disclose it. We're like, we're not operating in bad faith. And so we talked with some people at MSRC. But I still have a problem with it, right? And I feel like this meme sort of sums it up, right? Because Microsoft is saying it's a developer problem. Initially, when they still, Dscope disclosed this, it was at the core a developer problem. But Microsoft basically is still saying, right, like there's nothing that they're going to do about this. So this kind of gets into the defense and mitigation and what can organizations do about this vulnerability here, right? And so as that Forward CloudSec in June, and Matt Graber here from Red Canary, he was talking about something completely different. But I love that he basically had this slide that said you can't detect what you don't see. And I feel like this sums this up so well for customers when we look at this thing, right? So back to this big complex diagram here. right? If we're trying to mitigate this, and we're circling, right, the entra tenant for the customer here, right, there's things like conditional access, and, we can do MFA, and, Defender for cloud apps, and deploy third-party, CASB solutions, and all that sort of good stuff, right? But the problem is, again, because all the authentication, right, is happening in a completely different entra tenant, right, this is going to bypass any of those defenses, right? So there is nothing that a customer who is using a vulnerable SaaS app can do to mitigate this within their own entra tenant. So, we can look at other things, like maybe from the app perspective, right? There's a SaaS security posture management software, SSPM, right? But unfortunately, these sorts of things just look at how knobs and dials are turned, and right, they don't actually get into the underlying code of the application, right? So they're not going to really be able to tell you if the app is vulnerable. And there's other interesting things like push and security, and some other vendors that make like these enterprise browser things that have extensions, or it gives you more insight into what users are doing in the browser. But again, right, those aren't going to know that the application is vulnerable because they don't have visibility into the underlying code here, essentially. Right. So what are we left with here? So the only detection that could be possible, right, would be essentially correlation of sign-in logs, right, from SaaS applications. So in this example here, right, we sort of have logs on the right coming from that app, logs on the left coming from Entra, right, and we could say, oh, like we see an authentication attempt happening here, or someone authenticated the app, but there's no correlating Entra sign-in log, right, but like nobody does this. I mean, you'd be lucky to get even the large SaaS applications to easily give you data into a SIM, right? You think most of these like mom and pop shop sort of SaaS applications have easy integrations into a SIM. Never seen anyone doing this, even again with like huge things like Salesforce, Workday. It is a ton of work to get those logs in, right? And then if you're talking about authentication, you really need a lot of agility, right? If you have like a huge user base, to really be able to like have high confidence in correlating sign-in logs here, right? So, essentially we're just left with no defenses from a customer perspective. Right, and again, this again, my little meme poking at Microsoft, right, where, what can we do about this? And they're like, we can ignore it, or say it's a developer problem, or we can blog about it, which is basically all that they did. Right, where again, in our case we opened with Microsoft, we had said you could at least flag service principals for a customer, right, so they could know that that application is using this claim. It's up to the customer to figure out what they want to do, right, but there are ways out there that we think Microsoft could help customers at least understand, some of the risk around some of these apps if they're still using this. But there is a lot of mitigation that developers can do, right? So, I mean, it's simple, but they can fix their application. And Microsoft published a lot of guidance. Dscope published guidance. We've published guidance around fixing this. But again, like Matt was saying, right, unfortunately, the problem is many times the people that you need to sort of hear this message are the ones that are not, in this room, right? Specifically, though, if you develop software or you have multi-tenant applications, right, you can check for that remove unverified email claim, test, fix, test, and, fix and test your application. And I can't stress this enough, that one organization that we worked with that was really responsive, they initially had fixed it, but they had only fixed it in a region, right? So we were doing some testing, and coincidentally I was traveling, I was over in Europe, and I went and tested and said it was vulnerable still, and they're like, well, we fixed it. And then, like, long story short, right, is they found that they fixed like their region in North America, however their application was architected, but they didn't fix it in Europe. So again, just like looking at how that application works, right, but this is really all on the developer side, right, to be able to fix this. But this unverified email claim, again, this is something that we can go get in an attribute on the app registration. And if this is small, we have all this stuff in a blog article, and the slides will be available. So if like you're unable to read this, because I can barely read it, and it's 2 inches from my face, we'll have this all out here. But we can actually go look for this unverified email claim attribute on an app here. And then we can also patch it, right, to remove it. So say the app developer is like, well, we don't need this, right? We can go remove that unverified email claim, or set unverified email claim to true, right, so that the application won't be using this. The other thing is, though, is as I mentioned, right, that there is a legitimate need for applications sometimes to have an email address, right? So there is this other thing in OpenID Connect called the user info endpoint. And again, it's probably tiny here, but basically post-authentication, right, you can go ask Graph, and this is an OpenID Connect thing, so any developer that is using OpenID Connect should be able to, I mean, developers might argue differently, but they should be able to relatively easy go make a call to this endpoint and then get information about that user that authenticated, right, including that unverified email address, right? And this is after I've authenticated the app, so it's safe because it's post-authentication, right? Like, we've already verified I'm Eric by my subject, and we want to still just go get my email address, right? We can use the user info endpoint. So again, we have this blog post out here, and this is a short link I have. There's probably not anyone from Microsoft here, but Entra.ms, I will say, is for sale to Microsoft if anyone at Microsoft wants to buy it. But this is just a short link. We'll go to the blog that we have around this. Right, so, kind of like what are the key takeaways aside from my, ranting about, the industry and nobody on either side really caring about security, is that, right, no-auth is extremely dangerous, and this will continue to exist, right? Microsoft has no plans on sunsetting that, email claim within the ID tokens, right? So as long as developers don't follow standards, right, it's going to continue to exist, and it should be a concern if you use Entra, right, Microsoft 365 Azure, you have people signing in and using SaaS applications, right, and the customers are unfortunately stuck in the middle, right, like you really don't have any protection against this. I mean, this kind of, right, dovetails into, what you can do about it. Again, if you develop software, someone that develops software, right, developers, like, just please follow the spec. I've talked with them. They always come up with weird things. Just follow the spec and you won't, I'm getting ahead of myself, right? Follow the spec and you won't, find yourself in this mess. I do think there's an interesting space here for, red teamers, attackers, stuff like that, to continue to test applications for this. I actually think it could potentially be an interesting use of AI, and I'm usually not much of a fan of AI, but in this scenario, right, there's other catalogs out there of applications, like Microsoft's Defender for Cloud Apps has like 30,000 something SaaS apps in it. I'd love to go, through that and say, of those, figure out AI, right, which ones have a sign in with Microsoft button, and even potentially then go sign into the application, right, in a sort of attack scenario. But the problem is ultimately, even in testing these 9, right, you need to sort of be able to, you need to be somewhat familiar with the application and what you're looking for to determine if it's really vulnerable, right? In all these scenarios of testing, we basically would do some sort of data manipulation, right, as the attacker, and then go see it reflected as a legitimate user and say, yep, like, we're in as the same user account, right? And that's where I don't think something like AI would necessarily know what to do, because each scenario, right, you'd have to tell it, like, what it specifically needs to look for. But I'd say for defenders, right, so if you consume, SaaS applications, to ask your vendors about this, right? Either send them to Dscope, send them to our blog, right? Like, say, hey, are you aware of this? Do you know about this thing? Again, you could potentially go test your applications, right? But I think it's unreasonable to ask defenders in an organization that could have, hundreds of thousands of SaaS apps, like, go test all these things, right? I mean, to test 9 applications for someone that knew what they're doing, I mean, it took me, I'd say, 5-6 hours to do that, right? So it wouldn't really work in an organization for defenders to go out there and test. But well, actually, we only have a minute, and I know lunch is coming up. But I guess I will say, if there's any questions, I probably have time for 1 or 2. All right. Well, if you want to talk about this or any identity thing or Entra or whatnot, feel free to hit me up in lunch. And I appreciate everyone for joining. I know this got in the weeds, but thank you.